Welcome to Chapter 2, Section 9, Percents. As they standardize comparisons to a common base, the base of 100, percents can be very useful. In setting up proportions with percents, you need to consider that your percent is your part, and your 100%, your 100, is your whole. So it needs to be that way on each side. Your numerator needs to be your part, and your denominator needs to be your whole value. We'll see this in action in a bit. Here's an example problem, and this should be your first required entry in your notes. And we want to know what percent is 42 of 56. Well, your proportion can be set up like this. And once again, as in the last slide, you have 100 on the bottom, and that is your whole. And your part goes on top. Well, we don't know the percentage here, so we have X percent. So we don't know what percentage, because that's what the question's asking. So our X goes in that part. Now I put a percent sign there so you would know that it's a percent, but I just erased it because to put a percent over 100 is redundant. Now look at your problem. You have is 42 of 56. Now with the number of 42 and the number of 56, which is the part and which is the whole? Well, your 56 is the whole and your 42 is the part. Go ahead and use cross products. So we have 4,200 equals 56x. And of course, you can divide both sides by 56. And you know that x will equal 75. Here we have another problem. This will be our problem number 2 to put in your notes, the second thing I'll look for in your notes. Again, we're going to use a proportion to solve a percentage problem. We are still looking at part over whole. And on the right, our part is an unknown percent, because what percent? And of course, a whole in percentage is 100%. And now we're looking at the numbers of 40 is 2.5. Well, 40 is our whole. And 2.5 of it is part of that whole. So now we have our proportion set up. 2.5 times 100 is 250 equals 40x. Divide both sides by 40 to isolate the x. And x equals 0.25. So 6.25% of 40 is 2.5. Here's example number 3 that I should see in your notes. In this example, we have a dress shirt that normally costs $38.50. It's on sale for 30% off. What is the sale price? That's a big question here. What is the sale price of the shirt? Well, we'll set up a proportion. And again, we're going to do part over whole. And our whole is always 100%. Now, do we know the percentage here? Well, we know we want 30% off. But the question that's being asked is, what is the sale price? And that's what we really want, is that sale price. Well, that sale price is 70% of the whole. Take 100 minus the 30, and you're left with 70%. And on the left-hand side of the equation, again, you have part over whole. Well, we don't know the part that we're paying, the 70%, but we do know the whole is $38.50. Let's go ahead and use our cross products. So $26.95 is what we'll be paying. That is the sale price. Now we could have done this problem by solving for the 30%. And once we did that, well, let's take a moment and see what happens. We're going to find the sale price, but first we're going to find the 30% off of the $38.50. Now remember, this 30% is not the sale price, it's the part that comes off. So again, use your cross products. That equals 100x, divide by 100. So we have $11.55 equals x. Now, it might be kind of easy to say, oh, that's the price. But if you think about it, 30% is not even half. It's about a third. So you realize that this is the price coming off of the original. So then we need to take this price and subtract it from the $38.50. Do you see? Come up with $26.95 for your sale price. So it doesn't change the answer, just you have to do a few more steps. Here's example 4 in your notes. Fourth thing I'll be looking for. Again, we're going to use our proportions to solve a percentage problem. We still have a part. We still have a whole. Our whole percent is going to be 100. And as you can see here, we're giving a percent in this case. So we're going to put that in the percentage spot. And now we're looking at the remaining number. 125 of what number? So our unknown is the what number, the of part, is 17.5. Well, 17.5 is 125%. So it's going to go on top because it's the part. It's the 125%. And our unknown is the denominator. Go into your proportions. 125x equals 1750. Divide both sides by 125. And you get x equals 14. This is an equation that you can use to determine simple interest. Notice that you have a interest equals the principal, the original amount you invest, times the rate as a percentage, times the amount of time. Next, we're going to look at simple interest. This is an equation for simple interest. You have your interest, which equals your principal times your rate. Now, typically your rate is given as a percent, but you need to turn it into a decimal, times time. This is example 5 that should be in your notes. As you can see here, I've worked the problem. You have deposited a principal value of $840. It's going to create a simple interest rate of 4.5%. Look underneath rate, that's 4.5%, and that's going to equal 0.045. Now you turn into a decimal value. Time is 4 years. Notice I've done the principal, the rate is a decimal, and the 4 years. So my interest will be $151.20. Here's where you need to check yourself for understanding. There's only one question here. So this will be question number 6 in your notes. Here it asks you to place a check if it has a part greater than the whole and place an X if the situation does not have the part greater than the whole. And then at the bottom, make sure you understand percent, part, and base. Base I've also called whole. And rate how well you can solve percent problems. I'll see you in class tomorrow.